Hi everyone, this is my replication attempt of the William Skinner gravity torque assisted device, and this is the top of my unit. It's 8 feet high, and I'll give you a little bit of a zoom in here. You can see my top shaft being driven here, and there you're seeing a pillow block bearing there that is mounted sideways, and here is the upper bearing, and that is a 24 volt 400 RPM motor, and I don't drive it full 24 volts. And the gear ratio is basically the center gear here is 3.33 times the back gear on the motor. So the RPM is being reduced and to achieve about 60-70 RPMs. And now this is the lower area here where the upper shaft goes into a bearing, and that's basically a self-centering bearing. It's not the ideal bearing for this, but these are all bearings that I had available to use, and I've used them for this purpose. And there is the bottom with the weight here, and there is the bottom shaft there, and it has a generator attached to its bottom, and exactly the same 3.33 gear times to spin this other 24 volt motor, and these are permanent magnet DC motors, both of them. And there is the weight on my shaft, on the lower shaft there, and there is my weight on the upper shaft. And basically it's just cement, and I built that in a what they call a sono tube, cardboard tube, and I put different little, you might see cracks there, and basically they're just different levels, and I can add and subtract weights as needed. So I have some of them here, and then I have some others right there on the floor. See there, that's for the upper weight, and there are more there for the lower weight. I'm on a ladder right now, so I'm going to come down and give you a bit of a shot down here, and you can see the chain there to the motor here, and if I turn the shaft of the motor there, you see the lower shaft turning. That lower shaft there is 90 degrees here to its shaft, so it's an attempt to replicate what I've been observing on Mr. Skinner's device. And there's another bearing there, and below that there's another bearing, another pillow block bearing turned sideways, and that one there is a self-leveling bearing, but the shaft is straight to this point, and this is 90 degrees to the bottom there. Actually, it's just raised a little bit because of the weight. I figured it'd be best to raise it a bit. And the shaft used to be perfectly straight, but I've put this design here of tensioners, which are basically threaded, quarter-inch threaded rod, and they come here. And with that, I can create a tension, and I tell you, this works very well. That's under very strong tension. This shaft has zero flex there. So once I put it under tension and perfectly straight and true, then right now I have the two parts here detached. I'll attach them and show you that once it's functioning. So basically, once this shaft was under tension, I was able to easily arc it back to give the right angle so that these two here can meet up. And on the top here I have this little pillow block bearing, which is a self-adjustable bearing. So, you know, it's the same kind of thing here. It'll just find its level, and it doesn't stay, you know, the bearing just stays in there, because the bearing outside is made a bit of like a ball shape. And that's what I have here holding the upper shaft. It's the same thing. But once you hear that sound, that's because of the weight on here. These things are really not made to have pressure downwards. It's all the wrong kind of bearing, but this is just for proof of concept. And like I said, I had these bearings all available. These motors I had available. So all this is, you know, not costing very much. So this bearing that you see here, this 3/4 inch bearing here, that's a 3/4 inch shaft up on top. That's the same bearing up there. Sorry about the focus, it'll come into focus now. And I've just cut that all around the bearing, and it's epoxied around the rim of that bearing. And basically I drilled little holes around the rim of that bearing, and little holes in the piece of aluminum plate here. And I made this piece of aluminum plate so that it could be extended further out to give a bigger circle if needed. And as you see, there's little spacers on top there to keep it away from the chain. So this shaft here turns very nicely this way because of those two nice bearings. And that's also a self-leveling bearing. So even though it's on an angle, it can go on, it can swing this way. And perfect bearing inside as well. So that's how I was able to design that, and it works well. And like I say, it's not this is probably the worst part there, and that's what makes that sound once you see the shaft turning there. So what I'll do now is I'll pause the camera and I'll reattach this. I wanted to show that it separated like that, because that way I can turn and you can see that the level is, you know, working out here. By the way, this box is 24 by 24 inches square. That's a space I have in there, and that's just 5/8 millimeter. And this is all posts for kind of those like farm fences or whatever that I've just cut up and screwed together. You can see the screws in there. Those are self-tapping screws, but I pre-drill everything. Wasn't really using the self-tapping too much, but basically self-tapping its own thread and all that. So that went well. So here, these cross pieces here, that's for a reinforcement for when it, you know, for no rocking on this side, and obviously that's strong across there. And the bars underneath there to hold the lower bearing, that one there that's on the lowest part. Okay, so I've covered it up enough here, and basically we'll go to the next step and be right back.